So let's talk about reactive programming in Java. And look, we're going to skip all the dry, complex theory. Instead, we're going to tell a simple story. A story about a restaurant that I think is going to make everything just click. You've been there, right? We all have. You're using an app, it's getting popular, and then it just slows down to a crawl. It's super frustrating. Well, that exact problem is what we're here to talk about today. And the solution lies in a completely different way of thinking about how our software should work. Okay, to really get the solution, we've got to understand the problem first. So, I want you to picture a restaurant. It's busy, and it operates in a very traditional and, as you're about to see, a really inefficient way. So here's how this place works. A waiter goes to a table, takes one order, and walks it to the kitchen. And then they just stand there. They wait. While that one dish is being cooked, our waiter is completely blocked. They can't take another order, they can't greet new customers, they can't do a single other thing. They are stuck on one task from start to finish. And believe it or not, this is exactly how a lot of traditional Java applications work. Every waiter is like a single thread of computation. A request comes in and a thread gets assigned to it. But if that thread has to wait for something, like a database to respond, it just stops. It blocks. So what happens when the restaurant gets busier? Well, you hire more waiters, right? Or in our software, you create more threads until you just run out of resources and the entire system grinds to a halt.
But what if there was a better way? What if we could completely redesign this restaurant to be way more efficient, way more responsive? Well, let's step into the reactive restaurant.
This one simple phrase, it changes absolutely everything. In our new improved restaurant, the waiter takes an order, gives it to the kitchen, and says, "Hey, call me when it's ready." And then they leave. They don't wait. They immediately go serve other tables, take more orders, and keep the whole place running smoothly. And that is the heart of reactive programming. It's non-blocking because our waiter, our thread, is never stuck waiting around. It's event-driven because the waiter acts based on events, like a little buzz from the kitchen saying, "Hey, order's up." And it's asynchronous because taking the order and delivering the food are now two separate things that happen independently, not in some rigid step-by-step sequence. So you can imagine, in a really hopping restaurant, orders aren't just single, isolated things. No, they're a constant, never-ending flow. And reactive systems are built from the ground up to handle this continuous stream of data and events. Now, when we get into the actual code, specifically in Java's Project Reactor, this data stream comes in two main flavors. You can think of a mono as a single order, like a customer just asking for the bill. You expect one thing back, or maybe nothing at all. A flux, on the other hand, is like a whole dinner experience for a table. Appetizers, drinks, main courses, desserts. It's a whole sequence of items that show up over time. Okay, this all sounds pretty great in theory, but what happens when things get absolutely insane? I'm talking about the Saturday night dinner rush, when everybody orders at the same time. A good system has to be able to handle that pressure. This is where a really cool concept called back pressure comes in. Imagine the kitchen is just slammed with orders. Instead of letting them pile up into a chaotic mess, the chef yells out to the waiters, "Whoa, stop, I can only handle 5 more orders right now. Send me only what I can handle." See? The consumer, in this case the kitchen, tells the producer, the waiters, to slow down. This is what keeps the whole system from getting overwhelmed. All right, so we've got the flow managed, but things still go wrong, right? In any real kitchen, a dish is going to get burned eventually. So what happens then? Does the whole restaurant just shut down? Do you send everybody home? Of course not. The kitchen just deals with it. Maybe they retry the order and cook it again, or if they're out of an ingredient, they offer a fallback. How about the salmon instead? Reactive systems treat errors exactly the same way. A failure isn't some system-crashing disaster. It's just another type of event that you can manage. You can retry it, provide a default, or just recover gracefully without taking the whole application down with it. So, we've spent a lot of time in our imaginary restaurant. I think it's time we head back to the real world and look at the actual code and tools that make all of this possible. These are the big names you're going to hear in the reactive Java space. Project Reactor is the engine that gives us those mono and flux types we talked about. Spring Web Flux is built right on top of Reactor, and it's how you build these non-blocking web apps with the Spring framework. And RxJava is another really powerful popular library for doing this exact style of programming. And where do you actually use this stuff? Well, pretty much anywhere that speed and scale are absolutely critical. We're talking about high-traffic APIs that get hammered with requests, banking systems that can't afford to miss a transaction, streaming platforms that have to deliver video without a single stutter, or real-time dashboards that need to be, well, real-time. So as we start to wrap this up, what's the one big idea you should really take away from all this? It's not about learning one specific library or framework. It's about a fundamental shift in how you think about building software. And this right here is the whole ball game. Traditional systems spend almost all their time just waiting for a database, waiting for a network connection, just waiting. Reactive systems don't wait for anything. They fire off requests and then they react to events as they happen, staying productive and efficient the entire time. And why is this so important? Why does it matter so much? Because this mindset lets us build the kind of applications we need today. Systems that can actually scale to handle millions of users, apps that feel lightning fast and responsive, and architectures that are resilient, that don't just fall over when something goes wrong. So, I'll leave you with this one question. The next time you're looking at an application, whether you're building it or just using it, ask yourself, is this thing built like that old overwhelmed restaurant, built to wait? Or is it built like our new, efficient one, built to react?